Welcome back, guys. Partial fractions are what we're going to be focusing on today, and I am going to split it into two parts because there's a lot that goes into this. It's not difficult, it's just weird, and there's a lot to remember. So I'm only going to do two examples with this, just because each one does take a while to get through. But as we go through this, just try to follow along and see if you can understand why we're doing what we're doing. And the goal here is to split a fraction like this into two smaller parts. Okay? So first and foremost, I'm just going to say, well, if I want to split this into two smaller parts, it might help to factor the bottom and see what that could break into. So we can factor the bottom. We'll leave the top alone. There's not much you can do with that. But on the bottom, we will have an x minus 4 and an x plus 1. And that helps us because then you can kind of see what's happening here. You can see, well, if I added two smaller fractions together to make this, the old fractions probably had a denominator of x minus 4 and x plus 1. So you can basically just say, well, there's probably something over x minus 4 and something over x plus 1 which would combine to give me this. We have no idea what's on top of these two, but we at least know it's probably these two bottoms. Otherwise, there's no way you can combine and get this at the end. So what we do is we just say, well, I don't know what the tops are, so I'll make those my variables. And then you're essentially just going to try to put these two back together and see how you could get these back together and somehow get this on the top. Because we'll get the bottom guaranteed. We've set that up in the problem, but we don't know how A and B are going to combine here once we get common denominators and all that. But we're just going to take it through the steps and see where that takes us. Okay. So if we wanted to get these back together again, we would simply say, well, I know this has to be multiplied by x plus 1 over x plus 1, and the b's would have to be multiplied by x minus 4 over x minus 4. When I do that, I'm going to get the old denominator back, which is good, because I mean now I know that at least this part will be fine, and then I can watch what happens to the top. So I'm actually not even going to write the bottom at this point, because I know I've forced myself to have it. I'm just going to worry about the top. So a distributes to both of these. You'd have ax plus a. B distributes to both of those, so you would have bx minus 4b. And what you have to realize now is when you add these together, it's supposed to turn into this. So this top here that I've just created had better turn into 7x minus 18. If it doesn't, either this isn't doable, which is a possibility, or I just messed something up, because this is the only way it's going to turn into a fraction of smaller pieces. Now the thing to notice here is you can kind of mess with this side to help you see it better. If you group the x's together, so ax and bx, and then you group the constants together. Remember, a and b are just numbers, so we're going to put those together. It has to turn into this. It does kind of look a bit easier now, because you can essentially look at these x's and say, well, I know that's a plus b times x, if you just factor the x at the back of the problem here. And then this other part is a minus 4b. The thing you have to understand is what's helpful about this grouping. What you can see here is that, well, if something times x equals something with a 7x in it, a plus b has got to be 7. There's no other way that I can get 7x's going on here. So I know that a plus b has to equal 7. And so that's where the x's came from. The only thing that has no x's at all is this stuff right here, and that has got to turn into negative 18 if I want this to turn out at the end. So I know this, a minus 4b, has got to be negative 18. And that's kind of weird to change this problem into such a format where you're forcing the x to be lined up with this and the number to be lined up with the other number. But once you get to that point, it's actually very easy to solve, because now we just have a simple system here with two variables. So I'm just going to multiply the bottom here by negative 1 so that I can combine these together. So a with negative a is gone, b with positive 4b is 5b's, and then 7 with positive 18 would be 25. So I know that b turns into 5. And then pretty easy, just put the 5 back here of the top. A plus 5 is 7, so a has to be 2. We're pretty much done here. We've found the a and the b that makes this original setup possible. So your only final step is to actually write out the answer now. A is supposed to be 2, b is supposed to be 5, and so if we want to split our first fraction into parts, the only way it's going to happen is by saying I could do 2 over x minus 4 plus 5 over x plus 1. That will be how I split up my original fraction. Okay, so again, the process here is to essentially create two smaller fractions, put them back together again, and then line it up in such a way that you can see, okay, how many x's do I need? I need 7, and this is the only stuff with x's in it. What are my constants? This is my constants, and then make a system out of it. Okay, so that's the idea. We'll do one more that has a little bit of a twist to it, but it's going to follow the same procedure, and we're going to get something like this at the end. This next one, same idea. Let's factor this. Let's see what the bottom turns into, and we'll find out what we need. So nothing different on top. The bottom factors is x plus 2 over x plus 2. Now this is the weird part, is when you have a repeated factor. Because you might think what we did in the last problem, you say, well, I know it came from x plus 2 and x plus 2, right? Here is the annoying part. Think about what's happening here. If you had this, we would not need to get a common denominator because we already have one. So you would never force yourself to get x plus 2 if they were both singular. If you could add these together right now and there wouldn't be any reason to do that. So the thing we have to add here is you have to start at least one of these off with a squared on it. And this is the thing that people really get confused on, like why in the world would you have to do that? But again, just picture that if you didn't have this squared here, there'd be no reason to get two factors because you would just add them together immediately. Okay, so anytime you have a repeated factor, you just build up to that highest repeat. If this was like x plus 2 to the third, you'd have a single x plus 2, you'd have an x plus 2 squared, and then you'd have an x plus 2 to the third. We probably won't see any like that, but any repeated factors you have to build up to just to force yourself to get to the point where you have to have that type of thing going on. Okay, nothing else is different about the rest of this. This is A, this is B, and we're still going to get common denominators and solve. The only difference is now we don't need to do any work on this fraction because it has that denominator already. We only need to mess with that fraction. So let's get an extra x plus 2 here. And then we'll do the same thing, distribute the a into both of those, ax plus 2a. And again, this has no changes to it because it's already got the common denominator. So I'll have a normal b sitting there. And at this point, again, I know that x plus 2 is going to be the same denominator as that, so I'm not even going to write it here. All I know is that this has to turn into my old top. So this has to be negative 3x minus 2. And once again, we can kind of group this. So I only have one group of x's, just the ax. These two can be put together as well. You don't need the parentheses, but it kind of helps see the group put together here. And we know that has to equal this. So this one's actually even easier than the last because I only have one thing of x's. That means that these two have to be exactly the same. So a is just going to straight up equal negative 3. That's nice. And then the other thing for the b's, this has to equal that. So 2a plus b has to equal negative 2. And I know what a is already, so let's just plug that in and see what happens. 2 times negative 3 plus b equals negative 2. So negative 6 plus b equals negative 2, and we can quickly get that 4 equals b. Okay, so we have the a, we have the b. The only last step is to put those back in. Just remember that the a was over x plus 2, the b was over x plus 2 squared. So negative 3 over x plus 2 plus 4 over x plus 2 squared, and that would be your final answer.